Good morning to all. And this class, we started to talk about Chapter 3. This is the project management. It's quite a long, like a chapter. So include more solid information. I want you to, have, we will demonstrate together how to complete some of the in-class work. I gave you the in-class practice sheets today. This is number 3. Okay, and first one, it is a Gantt chart. So, and you don't have to start it right now. When we go to this topic, and at a certain point, I want we all look at this together. Okay, so, and in this whole kind of like lecture today, I cannot complete an entire chapter 3. Probably we need multiple times to complete the entire chapter. And it is it's project management. After this class, our learning kind of like objectives from chapter 3, we should be able to use a Gantt chart for scheduling, which is the first practice, in-class practice you see. I don't want you to start that right now. And then the second goal, and we wanted to draw AON networks. What is AON? It is the arrow on node. So there are two kind of like methods to draw the networks. AON, arrow on nodes. The other one is arrow activity. Excuse me, correction. AON means activity on nodes. Another network in the textbook, which is not our kind of like focus. So the textbook just touch a little bit and let it go. So for me, I think we should spend more time on AON network approach. So the third goal, it is to complete the forward and backward passes for a project. And this is the scheduling approach as well. So we'll see what is the forward path, what is the backward path. And from this path, we have to introduce a lot of concepts. Learning early start, early finish, and late start, late finish, and some other concepts. And then we can determine a critical path from your network drawing and from the forward and the backward paths. And so when we talk about a project and a project management, you can quickly start to think about what is the project. Actually, a lot of cases we deal with a project. Your class project, right? You assign a project you have to manage. The professor give you half a semester or give you 6 weeks. You need to think about, okay, when should I, start doing the research in the beginning, and when should I start to collect the data, and in the end, when you need to think about it's time to write a report. You have some kind of like a plan in the beginning. This is a class project. And in our home, we do like a construction and a remodeling project, or your landscape project, right? That's a project. Obviously, professors and the faculty members, they need to do their research. When we write a research proposal, we always have to give them a schedule. So we need to find out students to help to do the project, and what is the data collection plan. And after we design our data experimental study, and we need to give enough time to do the experimental try and error. Do we need to do any kind of modification about our plan? And after you modify and solidify your plan, you can do the real data collection. All these are all kind of like projects. Every day we need to think about, and as an individual, okay, we deal with the project, all right? And for management of projects, I think these are the three phases. So, and in the beginning, we need to plan the project. In the middle, we need to schedule the project. In the end, it is how do you control the project. That's the three phases in management of a project. But out of the three, I think planning phase, you need to think about 50% of the kind of like of the entire management of the project. Because if you do not plan this project well, it's going to be chaos in the middle of the process. And then it's going to, for sure, negatively impact the execution and the carry out of the project. So in the planning stage, we need to set up the goals, defining the problem, and also we need to identify, okay, the team. Okay, what kind of like character roles you need to and implement this project. And for example, you need like the kind of like a design engineer, you need to have the technician, you have to have some like a quality, like supervisors involved in this project. So you need to identify the people and the roles in this project. And then in scheduling is try to and locate or try to put the people, relate the people, money, and the resources to activities. So what do you need? Why you need a design engineer? You give them job, you give them assignments. Why do you need like technicians? Okay, you need to assign them certain jobs. You also need to think about, how long should the design engineer work about this job? 1 week or 1 month. So, and then with this, you can go to the top management and say, okay, I need this resources, I need this people. Please, support and some try to like convince them you need this many people and how long, 2 months or 3 months, and you need the support. After we have the two kind of like phases in the beginning, the very last phase is the control. Control stage is try to monitor the resources and try to monitor the cost and try to control your budget and make sure your activity really follow the schedule. So that's the three phases. And the project activities include planning and scheduling and controlling. Actually, I have already explained it all. And the thing we want to see over here is, and just give you the keywords. So keywords and under each phase of the under each phase, we have keywords over here and resources, and so monitor, compare, and revise and action. These are kind of like, in quality control, we call this is a diagram, we call this is a flow chart or whatever. This is just to simplify the organization of project management activities. So planning stage, here it is the second stage, and we need to put the schedule in specific kind of like techniques. We use techniques. This is a network. And the second one, it is, we assign people who is in charge of what activity. Then we have a deliverable chart. And the deliverable charts means, okay, it's very similar to be a Gantt chart. We'll give you example what is the Gantt chart. And then, and schedule the resources. And in this month, what materials you need and how you ask supply management to purchase the materials, so on and so forth. The last one, it is controlling the project and monitor the qualities. And do you have any delays? Why there is a delay? And you want to be careful. So, okay. So that's kind of like a big and structure and charts in project management. And in this project, in here, the highlighted things over here, we talk about, time. We talk about diagram. And we talk about material, kind of like resources. Another thing you want to keep in mind as a manager is cash. And because if you are out of cash, a business will be in trouble, right? Cash flow is something you have to think about how much you pay right now. And then the project investment, and in the future, how are you going to return the cash? You get some kind of like a profit, right? Because profit means, okay, when you invest this money, maybe you borrow from the bank, maybe you get the money from like from stock. That means you need to return some interest, correct? And also you have to think about you pay your employee. So this is the money you have to keep in mind. And also you want to make a profit. Profit is something you have to consider all of the costs. And then the profit is help your business grow, to help you to make money, put money into research and development. Without R&D, your business will stay at this level. You cannot grow. So in here, in this chart, we talk about a cash flow, and some kind of like money. I know our class, we do not really, talk about how to make a cash flow chart. But I think cost analysis or cost like management is part of technology management. It's part of like a manager's job. No matter you work in manufacturing, like industries, or you work in like a service industry. So we need to keep in mind, and there's some kind of like a cost. In this class, we are going to give you a seed or the concept in the beginning. We have to keep this in mind. Later on in other class, maybe you can have more. And in project management, we said we want to define the objective, define the problem, project statement. And one important thing is create the work breakdown structures. There is a big project goal. Underneath, you can break the big, like activity to small activities. And otherwise, you cannot assign the big activities to specific people. You want to break it down to be a smaller component. And then you can identify, say, hey, Josh, you are in charge of this. And Joe, you are in charge of, second part of this project. So this is called work breakdown structure. And then we determine the resources and forming the organizations. When we try to form a project team, and that means you have a project manager, right? That's very common for construction management companies. So they have the manager, and the rest of the team members, maybe supervisor A, supervisor B, and then they have some kind of like teams, members, individuals, and they work together. So this is a team. And very common, we see the project team is a temporary structure. That means, okay, and after finishing this project, this team will be done. Okay, the company maybe is going to have another kind of like a project. They are going to reorganize the project team. Maybe supervisor A is not needed. They add, okay, supervisor C and may add other people to the team. It's very common. I said I worked in the beginning. I introduced myself. I worked in a construction company for years. I have seen a lot of this is kind of like a temporary structure to form a team to take care of one project. After the project is done, this organization is dismissed. And then, but the people are still over in the company. They reorganize these people to do other projects. And use specialists from the entire company. And the team is lead by a project manager. Then the manager will coordinate the activities and among the entire team. Of course, they monitor and monitor the schedule and the cost. Here it is. I said, okay, and this is on the very top layer. So you see human resources, marketing, finance and design, and quality and production. But the project one team, they have the manager, project manager. They include a mechanical engineer, test engineer, and technicians. And these group, maybe the design is, this design is from here, certain people. In the second team, project number 2, we have a different kind of like design engineer. So this engineer is electrical. And also they have a computer science or computer engineer and from the company. And these very common project management is temporary. They will reorganize to be different team. The next team could be project 3. They need mechanical engineer and electrical engineer. They work together to design a kind of like or test the robots. Okay? And here is the organization. And this is saying when the project organization is useful. So when you have a project with a specific goal, deadline, construction project, normally, and the job is unique or somewhat is not familiar to the existing organization. You want to do some kind of like a prototype test in the beginning for a new kind of like assignment. You want to organize the project like a team. The work contains complex interrelated tasks requiring specialized skills. So sometimes it's not an easy work. Okay, you cannot squeeze all the people in the same project because doesn't mean you have more people will generate more result. Unless you are clear what you are doing, you need, I need 10,000 people. Otherwise, 10,000 people will not give you any kind of like a productivity, right? So complex interrelated tasks requiring specialized skill and temporary but critical to the organization. And project cuts across organizational lines. Could be, this as a kind of like they recruit people from different department. I talk about the work breakdown structure already. And when you have a big project, you want to break it down into small kind of like manageable like small activities. And then we can identify these resources for the activities, subtasks, and major tasks in the project. So that's the level. And here's the scheduling techniques. Scheduling is the very, 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 very important part of project management. When you have the very beautiful plan, you need to make the plan and implementable. And then you need to, design and make the schedule solid and manageable and also workable. So ensure all the activities are planned. And the order of performance is documented, because order is somehow is critical. Because if A is if they have a structure like this, and we understand, A, it is the structured, is the first kind of like activity. If A is the first activity, and B and cannot start unless you complete the A, then sequence will play a significant role, whether impact your or delay your like a schedule. So, and we will document the sequence or order, and the activity time estimate should be recorded as well. And the overall project time is developed. So these are the three kind of like techniques we talk about in this chapter or in this class. We use Gantt chart, and also we use the critical path method. And the third one, it is program evaluation and review techniques. So when we talk about a Gantt chart, the simple Gantt chart, normally you see it is horizontally, you have the time. Horizontally, we have the time. And vertically, that's the activities from order, from sequence. And you see here is the design. Design started from January, but they include the 6 months, from this Gantt chart. Prototype, the second stage, and some kind of overlap time with design. Started with March and in the end of April. So this is 2 months is part of the design as well. So test is halfway of the start, halfway in the prototype, but almost close to the end of design. And when in the prototype and the test stage, maybe we find some problem in the design, correct? Then we need to go back and tell the design team, you need to modify and recreate your drawing. Then you see these are all kind of like a part of the design stage. So, and then the revise even give a little bit longer time compared with design. This is a finalization. And then production. See, why they have overlap over here? Because even though you revise your drawing, and is still have some small chance in the early production stage, we catch some flaws, we catch the errors, then you want to go back. But of course, we want to reduce this possibility as little as possible. Once you release the drawing, you already ask the tooling people to make the tools and purchase the materials. And then you said, we started the production process already. You found out, we made some mistake. Unfortunately, you wasted some money. So this is kind of like we want to reduce this, overlap time, but that's the reality when you plan the project that you need to consider and think about. Simple Gantt chart gave you a kind of like a visualization how the time is going and each of the stage and what you need to do. What is the deliverable in the Gantt chart?
I have a question about the production. So on production, when it's drawing on the, is that like hypothetical, or is that actually when production for, say, the part, say these sunglasses go into
Production?
like actually you're starting to actually make the product?
Yes.
Okay,
I think
so,
it's true. It's a real production.
So then the test would have to be.
Yeah, the ideal situations you don't have any overlap. So, right? But so many times why people have a recall is because of something wrong, right? And this recall is even worse compared with here. If in the production like a stage, that means the product and has not been delivered to customer yet. It's caught inside. I mean, the mistake or whatever is inside the organization, correct? So it's already produced, started the production, but they found out the first 2 or 3 pieces of first 50 pieces not perfect. They want to revise.
So on the Gantt chart, the only thing that's actually hypothetical is actually the design of the. Everything else is actually done with hands-on. This is not a hypothetical. This is a real.
Yeah.
You know my question. I'm trying to. My question.
Here is we try to reflect what happened in reality in this chart, because the reality is I don't think the engineer can make 0 mistake. You see what I'm saying? If a design has some flaw, how can you catch the flaw? Sometimes the review of the drawing cannot catch 100% all of the flaws. Someone in the production stage, they found out, oh, there doesn't work. You need to change your drawing. That's the real things that happen in industry. I know some of the organizations, they have a very good review process. They try to reduce, try to catch flaws, but they cannot catch 100%. That's why you see a little bit of overlap. This chart is showing us, okay, it is possible you have some production and already started, but your design maybe need to be revised. You see what I'm saying over there? Like why people have the recall. You have heard the news. Ford they recall the truck, F-150, so many, and because they found some like a problem. And of course you think, oh, everything is done. I'm okay, but it's it's not okay. And if that's the safety hazard, you will be sued. And that's from the customer and producer relationship. But inside the organization, it is very common you see some, they stop the production of certain parts because they found some problem. Did they review and check their drawing before release to production? Yes, but it cannot catch 100% of the problem. Thank you, Drew, for your comment. Here I'm saying just, we are talking, use this example to show what is the Gantt chart. And the Gantt chart just basically give you a visualization about a project implementation, project like a result, what is the time kind of like span. And here, my first kind of like in-class work. So I want you to go to e-learning. Can you open my Excel file? So I need to delete this one. And this is a simple Gantt chart I create using Excel. So on the left side, I gave you this data already, right? I just want to let you see, okay, this is activity A, B, C, Ds. And then I gave you the start kind of like and date and end date over here. This column I added by myself is just kind of using the Excel function days can calculate how long of this activity will be. And here, this one, the horizontal, I gave it its timelines over here. And in the giving kind of like a data, it's from starting date. And January 1st to the end date, it is September 9th. So basically, I have a kind of like a horizontal to show, okay, January, and in the end is September. And from the horizontal bar, what I did is I just simply insert a shape. So it is a horizontal shape. For example, I can insert a shape like this. And I have already generated this chart for you, but I want to explain, if you do not know how to use the basic tools in Excel, like insert object, insert shape, that's what I do. Okay, here is from January 1st to May 1st. So I started over here and in the end it is May 1st. And by the way, this chart is not perfect, okay? It is the rough drawing. I did some research about a Gantt chart using Excel, but you need to, somehow you need to purchase a small patch of the software. I don't want you to purchase that, okay? And if you work in the industry, so some of the industries, they already purchase a project, Microsoft project. They have the tool already, okay? And I think before 2005, Microsoft project was a standard portion of Microsoft Office software. So Office include PowerPoint and Word, and also include Excel and Access, and include project. But now they sell projects separately. And I'm seeing over here, I want you to be familiar with this. And if you are working for your class project, you can simply use this to create a Gantt chart. So no fancy, purchase from some other kind of like website you have to pay. Am I clear about this? How I created this Gantt chart for in-class practice? I did this pretty much for you. I said it is not perfect. It's just the rough idea and the visualization, but I try to match the starting point and the end point. And for the second activity B, is from January 15th to June 1st. So in the middle of the January and in the end of kind of like May. So I try to match this question so far about this. Are you okay to understand how I created this chart? All right. Okay. Thank you. And if you do some research, I already did. I see some Gantt chart free kind of like a download. I didn't really download because I know we are not allowed to download over here. I cannot install the Gantt chart for our class to use, because the university IT, they have a security kind of like a policy over here. And but simply we can do this Gantt chart over here. All right, we are going to spend some time, a lot of time, about PERT and CPM. And CPM is a critical path method, and PERT means program evaluation review technique. Okay, these both, we call them network techniques. And they were developed in 1950s by the industries because of the critical kind of like a project and a big project management, and by DuPont and some other companies. In both of this method, we have to think about precedence. What do we mean precedence? That means, okay, for example, and B cannot start and before A completed, right? This is the per sequence. That means you have to follow the sequence. And we use a different kind of like estimate of activity times. What do we mean for the last kind of like a bullet over here? For CPM, we use one single number to estimate the project completion time. So, like for example, for activity A, you need 2 days. For activity B, you need 10 days. You only use one good estimate. But for PERT method, no, you have to consider probability. They give you some kind of like 3 numbers to estimate an activity. And the best situation, everything work, the shortest time, it is 1 day. Most likely 3 days. In the worst case, maybe you need 6 days. So they give you 3 numbers in PERT method. We will see, you have to use the probability in that part. You have to estimate what is your average. They call average as expected time, expectation. And also you need to consider variance and standard deviations in PERT method. So PERT method we probably will talk next time, okay? There are 6 steps in PERT and CPM. First, we need to find out what are the breakdown structures. Individually, you need to break the project to be A, B, C, D, E, each steps, okay? And then develop the relationship among the activities. And we need to decide some activities must be completed first. And some activities you cannot start unless you have already the prerequisites have been completed, right? Like you take the class, you have to take the stat class, you have to take some math class before you go to the next level of the manufacturing technology class. So, sequence. With this sequence and the relationship, we can draw the network connecting all the activities together. Now you see a network from start to the end. So then we need to put all the time, assign the time and the cost estimate to each activities. A, B, C, D, how many weeks, how many days you can complete the activity. This one, it is a critical path because CPM means a critical path method. So from the network, we can decide or we can calculate what is the longest time. Actually, critical path is the longest time of the project. Uses the network to help plan, schedule, monitor, and control the project. This is a CPM is going to give you a kind of like a network visualization. Oh, I have to complete A first. I have to complete C before E. So, and there are two kind of like network technique. One, it is AON. AON means activity on node. And AOA is activity on arrow. And this is a sequence. The first one, A, is easy to understand. A comes before B, which comes before C. It's a sequence. A, it is the prerequisite of B. B is the prerequisite of C. And very easy to understand. You just put arrows. A is the activity on node. So you have the circle representing node. And activity on arrow is to say, oh, A, this one, A, it is activity. And then this is, they call them event. Circle is event, circle is event, circle event here. But it's very confusing sometimes, okay? This technique, pointer, and then they call, here is activity. And this is called event. So the circle is the event. In our book, if you read it carefully, they tell you they only give the resource and the time at A, B, C. For the event, you just assume nothing happened over here, just a certain point. You do not consume any resources at the arrow. So that's why somehow the book, I feel, doesn't recommend this approach. And they said, okay, the book used a lot of examples to show activity on node. And because it's clear, and A representing the event and activity, and then it will be assigned with money and resources, and then take time to finish the work over here. And B is saying, okay, B, A and B, they are both the prerequisite of C. A, B must be both complete before C can start. So C, this one, is showing activity A is the prerequisite of B and C both. So the arrow pointing, and in B is A and B both go to C. And the arrow in C, this example is showing, okay, and this arrow goes to B from A, this arrow goes to C from A. And now we see some kind of like, oh, here, I think, they call some kind of like a dummy activity. I don't like this at all. Okay, it's going to confuse you. See, now we see some kind of like a back and forth, interaction, or the network becomes more kind of like a complicated. So in this situation, in C and D cannot begin until both A and B are completed. That means A and B, they are both the prerequisite of C and D, correct? And then for the E example over here, it's saying C has two prerequisites, A and B, but D only has one prerequisite, B. And this one, it is okay. And A and B, they are the prerequisite of C over here. But this one, because, and see, it's very clear to identify, okay, A and B, they are the prerequisite of C. And D only has one prerequisite. But this one, and A and B, they are the prerequisite of C. there is no arrow. They have to add the arrow to represent B to C. They call this is the dummy activity, and it's so confusing. It's so not easy. I just ignore this. The software, Microsoft, they provided the like a project management like a software. They didn't use the activity on arrow at all. They use the activity on node. All you see is similar like this. Okay. So for this one, the activity on node for situation F, A, B, and D, they are kind of like in sequence. But they add one C over here. A, it is the prerequisite of C. C is the prerequisite of D. But there's no relationship in B and C. So with this, we want to practice the example only for arrow on activity on node example. This is the Milwaukee papers manufacturing activities and processors. So we have the project, overall project breakdown structure A, B, C, D, E, F, G, and H. Totally, these are the activities. And so first one is build internal components, then modify the roof and the floor. C is construct the collection stack. And D is pour concrete and install the frame. E, build a high temperature burner, and then is try to install the pollution control equipment. After that, they need to install the air pollution device. And in the end, it is totally inspection, test, run the equipment to finish the project. And see, we have the relationship of the prerequisite. You see, A and B, they can both start that. They have no kind of like any prerequisite. Okay, there's no sequence. But C, C cannot start it. Cannot be started until A is finished. A is the prerequisite of C. However, D has two prerequisites, A and B. So E you see over here, E has the prerequisite of as C, correct? Because C, already has a prerequisite is A. That means, okay, even though you didn't see A over here, we understand A must be completed before C can start, correct? Prerequisite. And then A actually is a hidden prerequisite of E, right? Do you see the prerequisite? Hidden prerequisite. Some of the classes you see, chemistry is the class of a prerequisite to 2072 materials. But chemistry has a prerequisite of pre-calculus, hidden prerequisite. Okay. And with this is a very important kind of like information we are given. We try to draw the kind of like network. I want you to have this paper in your kind of like hand, right? Because I'm not sure whether you can see this clearly or not. I gave the table, but the table have a very small kind of like font. So we gave the start point, start of the activity, A and B, and they can both start the right way, correct? So there's no kind of anything kind of like in the beginning, unless you give the kind of like pseudo start point. So A. In internal components, B, it is a floor and a roof. Then you go C. C is very easy because, C it is after A. So after A. But D, see, D has two prerequisites. So both A and B. Correct? We draw the two arrows toward to D. And the next one, I want to see, okay. The next one I want to see is E. So for E from your given handout is E has the prerequisite as over here. So this is E, right? So E. And for after E, we see, oh, we have F as well. F also have a prerequisite and prerequisite as C, because if you look at F, F is F over here. And then we have G. G, both D and E, they are the prerequisite of, oh, okay, you don't have it. Okay. Mm-hmm. G. Because G has the two prerequisites, both E and D. So they should do toward over here. And in the end, H has two prerequisites. So this is H. Okay, I do not have a very good kind of like handwriting, some kind of like tool in the computer. So if I discard this, now you can see a better kind of like drawing to show you the structure. I said this is important when you do your work. You need to keep all of the, this information available to your hand. Then you can draw this structure. So, and C with is a prerequisite. It has a prerequisite. E has a prerequisite C. F has a prerequisite C. And G has two prerequisites, both and D and E. And H have both. So in your, okay, so this is the practice I want you to do is I have all of the activity cable are available, right? And then let me tell you a secret. So the secret is because this is the in-class work, I still want you to submit at e-learning. I want you to generate an electronic file. I want you to use your copy screen is there's a blue, do you see in your keyboard there after insert you see print screen, do you see that? Okay, hit this key, print screen, and then go to paint, P-A-I-N-T, and then you can Control V paste over here. Oh, did I print anything? Why? I think, oh, yeah. there is a, I don't know, let me see your keyboard. Do you, your keyboard is the same as mine? Yes, you have the, you see the keyboard print screen, it is the blue font, correct? You need to hold your function key and the print screen together. Fit the two together, otherwise the function won't work. So, and come to this page. Hold your FN key and the print screen together. And then go to Print, Control V. Now you have this. Right? And then we can crop. Go to your in-class practice 3. You can paste it here. Yeah, function and this together. Yep. And then go to Print. Go to here. Print. P-A-I-N-T. P-A-I-N-T. Yeah. No.
Is that what you
No. P-A is kind of like a drawing. Yes. Yeah. Yeah. Copy paste over there. Yeah. Whatever software you use, if you are familiar with others, that's fine. I use Paint, so it's easier for me. If you want to draw, and you need to use shape and draw a circle. You know, here also you can insert your text. Insert. So, let's say I want. You know, you can draw, but it's going to take a longer time. So I just want you to copy and paste. Did you get it? Yeah, you search over here. P-E-I, yeah. And yeah, it is there. Let's say you use the crop, select. Yeah, actually just copy this. That's okay. I don't care. Yeah. Yeah. Yeah, you can go back the reselect. Yes. Reselect and use the crop. Yeah. Okay, and copy and to your Excel. Because this is the in-class, you know, to save time, I just let you copy and paste. If you want to do your homework, and you know, sometimes if you want to draw a similar network, you have to insert like a shape, circle shape and arrow shape, and then finish this part. I do not talk about this one, arrow on activity on arrow. is going to be a chaos because of the dummy and lines. Then the next part is to determine the project schedule. So we are going to work together to find out what is the critical path. And then the definition of a critical path, it is the longest time passed through the network. So this one is not true. Okay, critical path is the shortest time in which the project can be complete. No, critical path is the longest time to complete the whole project. And any of the delay in critical path activities will delay the entire project. And in this Milwaukee paper example, we see, from the starting point, A, you can go to the path here, from the A, C, F, H, or A, C, E, G, H, or A, D, G, H, B, D, G, H. You need to compare which one is going to take longer time. And then from the different paths, you need to compare, okay, so maybe some of the activities is not a critical one, some it is. Any activity in critical path activity, so delays the project. And also we see critical path activity have no slack time. That means the slack time is 0. So we will give you a definition what is the slack time when we do the analysis. And in critical path method, we are given the time period. So for example, A, you need to finish this in 2 weeks. And H, we need to finish this in 2 weeks. Total time 25. Total time 25 doesn't mean the longest path to finish the project is 25, because some of the activities, they can be concurrently carried out. So we want to find out, then what is the longest time? Ideally, we can finish the project. And to determine the critical path, then we need to define what is the earliest start time, what is the early finish time, what is the latest start time, and the later finish time. Obviously, this one is very easy to understand. Early start. Early start, it is the earliest time at which the activity can start, assuming all prerequisites have been completed already. But the earliest finish time is at which an activity can be done. So first we explain the two, early start and early finish. And because in the first analysis, we call them forward analysis. Forward analysis is saying, okay, we start from the beginning, from A, then moving to B, to C, to D, and to H. This is moving forward. For the later start and the later finish, we go backward. So how about we started with the last activity H, and then we go back to C. How about a G? How about F? And then you go backwards until A. So there are two paths. In forward path analysis, we only consider early start and early finish. Okay? And this is the activity circle. In this activity circle, there are certain numbers you want to kind of like all symbols. So, and in the yellow part on the top, they give the name. And on the left side, you see ES, early start. This number representing early start. And the EF, and this is a number representing early finish. These two as a blank. And actually, it's not this stage yet. When we talk about a backward path, this is a late finish. And on the right side is a late finish. And on the left side, it is a late start. So this number 2 representing the activity durations, how long you need to complete this work. So late start and late finish. So this is the activity symbol or drawing. And then the forward path. Begin at the starting event and work move forward. We have to keep these two rules. This first rule is simple. You know, it's just saying a simple pull request. An activity has one immediately predecessor. Its early start equals to the early finish of the predecessor. That means you cannot start until the previous one's finished. But if you have multiple pull requests, it is the early start is the maximum number of all the early finish value of the pull request or predecessors. So this one and the second rule, you can simplify this as a maximum number of early finish of all the immediate pull requests. So, and then what is the early finish? Early finish equals to early start plus how long the work duration. So it's the activity time duration. Early finish equals to early start plus activity time. So now we see, we put the formula over here, you understand early start equals to ES, early finish equals to ES plus the duration. Duration is here. And in the very beginning, A and B, they have nothing in front of it. They give the kind of like a pseudo point as a start point, everything is 0. And then for A early start is 0. And what is the early finish? Just 2. Okay, so it's 0 and 2 as a start and a finish. So they put A over here. B is the same because A and B, they both can be carried out concurrently. So they have some overlap. They can start it right away, both A and B. And they have the same early start time. But B, its finish time is at 3 weeks. 3 weeks later. This is 2 weeks later. How about a C? C has the pre-request of A. A finish and C can start. And A's early finish time is C's early start time. This 2 and 2, they are equal. So this number this number equal. So this is early finish. Finish this one right away. They can start at C. And C's finish time equals to the early start plus the duration 2 equals to 4. Okay. Next one is complicated. You need to use the maximum rule, okay? So I will stop here, and we will continue next time. Yes.
We have to save this.
Yeah, just to save what you got. I need to use this to track who is here, who is not. Okay. Thank you, Christian. You reminded me. Otherwise, yeah, I did. I bring it. Okay. I want you to sign on the first page. Okay, not the second page. Okay, just pass around.